All right. So last time we did look at some of the organization of code. I hope everyone got a chance to at least practice the functions part, because the other conditions part, the if and if else and the nested if else, is pretty common to most programming languages. So if you had experience with any other programming, or if you remember slightest bit of C, that is not a difficult concept to grasp. And but the functions is something very useful to R and R programming, just to organize your code, reuse it in a way that is more efficient. Your code will be cleaner, and you can make use of your functions over and over, and you can test it only once and use it several times. So we'll start from right where we stopped in the previous session. We did look at if condition and if else condition, where you test a condition right after if, and if that condition is true, you will have executed a block of code. If the condition is false, you want a block of code to execute. If the condition is false, you will use the if else statements. And last time I quickly skipped through this, but this is a nested if else statements. It is kind of important. You will be in a position where you might need multiple conditions in your code. So let's walk through this example once again. So what I have here is nested if else. Just see if I can use my whiteboard. All right, so if you observe, this is one construct. You see one if and, sorry, that's not it. You see one if and one else over here. And within this else statement, you have another if and if else condition. So usually whenever we have more than one if and else, and whenever we have conditions, the way in coding we do is to indent it. That means have conditions within, if you have conditions within conditions, you use some space before using the condition. So if you want to particularly show the code within this if else statements, you will provide some space over here and then write your code. That is the use of indentation, just for readability. So what you see is within this if else, within this else part, if you notice, this whole thing is within the else, and this if else statement is within the else part of the code. So essentially what we are saying is, if the client value is equal to private, and if you might have noticed, there is a double equal to here. So it in R, it's a comparison operator. The double equal to over here and over here. If you want to check the value of a string, you will have to provide not just one equals sign. Just one equal sign stands for assignment operator. It's similar to this operator, which means you are assigning some value to a variable. So if you just give one equal, it is similar to this backward arrow over here. But if you want to compare the value hidden in a variable to a particular value, you'll have to use this double equal to sign. So in this example, what we are doing is we are testing what the value of client variable is. Say if client variable is equal to private, then we want one part of the code to be executed, which is within this if statement. This is the line that we want to execute. The total price is net price times 1.12. And if you remember from our very first class, this is a comment over here because it starts with a hash sign or a pound sign. And whatever you write after that hash sign is not considered code. So you're just commenting this code by writing a hash, and you just want for your readability and for your reference later on, if you yourself, just to remind yourself that it's a 12% tax basically. And this is a comment. You can put any number of comments over here, or you could add a comment line right before this. So let's get back to the code. You are giving a particular line of code that has to be executed if the client value is private. If it's not private, then you come to the within the else part of the code. So why is this necessary? Why is this if else statement necessary? If you have just two values or two conditions that you want to test, if you have just true, which means you are looking for a client equals private or not, which means if you give the first if and else only and not the condition within this, you are assuming that the client values can hold just two values, private or not private. So private or not private, and not private can be any number of values, but you don't care. It comes into this block of code. But we have another condition here within this else block. Say it's not private. Yes, you come into this block and you're checking if that client value is public. For a public client, you have some other condition where the total price is net price times 1.06, which is 6% of tax. And if it is neither private nor public, it comes to this line of code where there is no tax. So public or private. So the other can be an international company, right? So for international companies, it means that there is no tax, at least in this example. So I would highly encourage you to try this in your time. And I think I sent you this slide, but yes, let's go on to the next example. Okay, so our next example is the switch function. Is that right? Yeah, switch function. This is also another function that is based on conditions. So until now, for the conditional testing, we went through if statement, just the if statement, if else statements, and if braces, if condition braces, and else braces. And we also, if you remember the last class, we went through if else as a continuous if else function. So for values which are vectors, for vectorized operations, you can use the if else condition. And similarly, there is another condition called switch, conditional function called switch. So switch operates on several values. So you can select a number of values based on a condition. So for our client value that we just looked at, the example that we looked at, switch is a better function for us to test the value of a client. So switch operates on one single value, which is going to be the first argument that you're giving to switch function. And this does not take vectors. It operates just on one value, and based on what the value of that first argument is, you have to provide it a list of choices based on the value of the first argument. So one such example, which ties to the previous example, is if the client is a public, private, or abroad. If the client variable can hold three values, it can be public, it can be private, or abroad. So based on the value of the client variable, you can assign particular numbers or particular values. You can select based on particular values that and choices that you give right after the first argument. So in this case, we are saying switch, and the first argument is always the value, the client. Based on the client's value, select one of these three values. So what we are saying is private equals 1.12, public one value for public and one value for abroad. Based on the client's value, it's going to, if it's public, it's going to go here and pick public equals 1.06. This 1.06 is going to be returned by the switch statement and going to be assigned to VAT over here. So similarly, if it's private, VAT is going to be 1.12. So just based on this, let's look at, you can just try this one in our session. So first, let me do it. Let me put the client value as private. And if I do the same thing that I have in my example, use the switch command, the first argument is going to be the client, and we are giving it a series of choices. I don't remember the exact values, so I'm going to give my own values. And so we could check what the VAT has now. Since I assigned client to private, we are having set this VAT variable to 1.06. So similarly, you can use this statement within the function, or within a function, or within the if-else construct. So you could use this instead of the series of if-else statements or nested if-else statements example that we just saw. And this is a better way and cleaner way of writing code rather than using those conditions testing if-else. And this is not always possible. You will have to have one single value that you're testing. But if that is what you want to do, then this is a single line of code will replace that 6 or 7 lines of nested if-else statements. So any questions on this? Okay. So let's look at our next example. A repetition with a for loop. So for loop is one of the most common loops that you will be using in our programming. So for loop usually is a loop for selecting or doing the same, running the same block of code multiple times. So like every function or every condition testing function has a syntax, right? So for loop also starts with a keyword for. It does have a keyword for. You have to open the brackets and have an identifier within the brackets, within the round brackets. So here, for example, in this example, what we are using is the identifier is I. So you can call it identifier, or you could call it a count or a looping variable, which is going to be different based on which loop or which iteration that for loop is executing. And this identifier variable is followed by a keyword, another keyword called in. So you're saying I in, and you give it a vector of values to loop over. And then you execute a block of code. So this will be more relevant if we explain it through an example. So let's start our example. What I'm going to do is writing the keyword for, and I'm opening my round brackets, give it my identifier, and give it the keyword in. And going to give values. But here, I don't have anything in values. I have not set values to anything. So I'm going to set my values over here. I'm going to give it 1, 2, 3, 4, 4, 5. And what can I do within the code? I'm just going to print I. So if I execute this function, you will see on the bottom that it's going to print the values. So basically, what is happening here? Why is it not printing? When I have values, when I just try to print values, it's printing all my values in one vector, right? But why is this loop not printing it in one vector? It's printing it as 5 different vectors, and it's printing one value of these. So that is the use of for loops. So for loops are generally used to loop or iterate over every element given in the values. So this values right now has 5 elements, and for loop is supposed to loop over every single element. So the very first iteration, what happens is 1 gets assigned to I, and then it will go within the loop. It will print I, which is the value 1. It gets outside the loop and goes back to the second value. Now I is going to be 2, which is the second value. It's going to print 2. It ends the loop, goes back to the next value in the iteration. So that continues until all the values in this variable are finished. It continues until it gets to the last value. So that's why you have all the values as different numbers. So same thing, instead of this, you could do, if you want to loop through a sequence of numbers, you could just replace, you don't even need these values. You could just call 1 to 5 over here, and it's going to do this very same thing. And this can be any alphabets or any strings also. I could replace this with strings. Maybe call it so I have strings, and then I call, so you present these characters within the loop, and if I want to avoid that extra step, I could directly give it over here. And it's going to do the same thing. So whatever you give here is an important step. So if you have, say a vector with 100 elements, say I'm assigning values from 1 to 100, and say 2 to 34. You should have a combine here. So suppose if I'm running this, then what will my values be? There will be some numbers, right? And I don't know how many numbers these are, maybe length. How many values do I have? So I have 133 values within the values function. So suppose if I want just the top 50 from the values, right? So what do I do here? I could just say values 1 to 50. I could do this. So it's going to print the very first top 50 over here. And for most of the times what happens is, if you want to iterate over a matrix, say, and think that values is a matrix, so what we do is, if we don't know the dimension of the vector, we would just use the number of rows. If we want to iterate over a matrix, we would just use dim of matrix and give it the number of rows. So you might have remembered that if if I have a matrix, the dimension of a matrix gives rows and columns. So the first value in writing the dimension of a matrix, the first value is the number of rows, and the second value is the number of columns. So if I want to only iterate over the number of rows, I give it this, which is a square bracket 1, which means I'm iterating from the first row to the total number of rows, to the last row. And similarly, if I want to iterate over the number of columns, what I do is I'm starting from the first column to dimension of the last column, which is the dimension gives the total number of columns. So 1 to the last column. So this is the way you use it for a matrix or a vector or a data frame is more useful than simply iterating it over numbers. So any questions with the for loop? All right, so let's look at our next looping. So I have one example here where I'm combining everything that we learned until now, which is, if you remember the price calculator function from the previous session, we have a price calculator, and based on the number of hours you worked, we have a price per hour, and we calculate the product of the number of hours and your price per hour as the total price. And then based on the client, we assign the tax. So let's combine everything in this example, and let's try this example. And also in today's class, we looked at the switch function. We also looked at the for loop. So let's combine all these into one example and try to implement that example. So in this function, what we have is, if you remember our price calculator example, and the way of creating a function is by assigning to a variable the keyword function, the arguments that the function takes, and the piece of code that it runs. So this is the way of assigning a function to a variable, and then this becomes a function. So someone has problems with audio. Is everybody else be able to hear me clearly? Is everyone having problems with audio? Okay. So Mahesh, I would like to, so you could just log out and log in, try once again. Okay, all right. So let's continue with this example. So if you remember from our last class, we have these arguments as hours, the price per hour, which is 40, we are setting it to a default price, and we have the client argument. So what we are doing here is calculating the price, the net price, as a product of hours times the price per hour. And this is the shortcut that we saw previously. If else, we are using that function, and we are checking if the number of hours is greater than 100, then we give a discount to the client. We put hours times 0.9, or if it's lesser than 100, we give it the full hours. So this is our calculation, and this is our shortcut from previous session. So we come to the next part of this function, which is the VAT. First, we are assigning the VAT to a numeric. So by doing this, what we are saying is VAT is a numeric value, and it holds the numeric value of 0. So, and then we use the for loop over here. What we are doing is we are iterating through client. So this is particularly useful if we are giving a client as a vector, like previously I told you, if client is just one value, this loop is not really needed. This loop is going to run just once. Instead, we could just forego this loop and have just this statement. And this for loop is important and necessary if your value of client is a vector instead of one single value. So within this for loop, what we are doing is we are assigning VAT to a value, and VAT is going to be a certain value based on the value of the client. So here we are using the identifier because if client is a vector, suppose you have 2 or 3 values within the client, then I is going to be looped through each of those values. So first time it loops through, it's going to take the first value of client, and based on that value within the switch statement, it's going to pick one value from these numbers. So here, this is actually a good way to write it, because here we are saying private equals a number, public equals another number, and the third one we are just assigning it 1 without giving it any value, which means client can be more than those 3 values. Previously we had abroad equals 1, but here this way what we are saying is, if say somebody makes a typo, or you have more than the 3 values that we are expecting for clients, then it goes to this default value. This is supposed to be like, if it's not private, if it's not public, then it's this value 1. So based on the conditions and based on what the value of client is, VAT will be decided, and VAT will be stored for this loop. And then next what happens is we have this total price that is assigned to, that we have calculated for net price times the VAT. And then this last statement, if you remember from our previous classes, in a function, the last statement that we type, or the last value that we print, is going to be returned by that function, even if it doesn't have the value return, doesn't have the keyword return over here. So this is what the function is going to return. It's going to round the price and return that one. So if you remember, we had created a data frame, but you don't have to recall what data frame we created. We are just going to assign a client values to a vector which has these 4 values. So because we have this for loop over here, it's going to loop through the client and give assign VAT and have a value for VAT for every single value of this. So if you remember, so why am I doing this combine VAT over here instead of just assigning the switch part to it? So if I had just assigned the switch part to VAT and not had included this combine VAT, the value of VAT will change for each of those 4 iterations of these clients, and the previous value would have lost. So whatever the last value VAT will have is the value for client equals abroad, and all these previous values would have been lost. So that's why I'm combining. By doing this, what I'm doing is I'm combining whatever previous values we had for VAT with this new value that's going to be for that particular iteration of client. And therefore, VAT is now going to be a vector instead of one single value. So later, if you call that particular function price calculator, and you give it some hours and you give it the type, it's going to give values for each of those client types and hours. So if you want to try this example, you're free to try, but let me quickly go through just this part of it. which is the most important part of our function. So let me just go back to my RStudio and write my function once again, price calculator. So you remember how to write this function, right? So you have to have a variable to which a function should be assigned, and then the function will have certain arguments, and then within braces you have the piece of code that you need the function, the function, just a function, what a code that belongs to that function. So in this we have the arguments that need to go into this function, for which I have hours, the price per hour, you have a default value. So you can give defaults to anything. You can maybe default 1 hour if you can have that. And the third value is client. So based on this, we have a price that we have to calculate based on the number of hours and the rate. And using if else, we are giving a discount to the client based on PPH. So if else, sorry, not PPH, it's the number of hours. If the number of hours is greater than 100, you give a 10% discount to the client, which means you're calculating 90% of the total price. And if it's you can give a space or for more readability, but it's going to work the same way even if you don't give a space. And if the hours is lesser than 100, you want to consider the full price. And now, based on, we are just going to assign the VAT to a numeric 0, and based on the client value, we are going to loop it through a for loop. And then we are going to calculate the VAT and combine the VAT with any previous values it has. Now we are going to use the switch function. Switch function, you're going to switch based on a value which is going to be not the client, but I, because client, remember client is a vector, but I holds one single value for one single iteration of the vector client. So based on I, you're going to assign what it's going to be, public, private, and default, if it's not public or private. And once you get outside the loop, the for loop, you have the total price, which is going to be the net times the VAT. And lastly, if you don't write anything after this, the total price is going to be returned, or you could use round, or you could use just the total price if you don't want it to be rounded. And I'm going to run this function. So remember in our last class we saw that there are several ways to run a function. You can either put this piece of code in an R script and call that particular R script using source, use source, and then give whatever the R script is. And of course that's not going to run because that script is not present. And during this, if the current directory is not where your script is stored, you can use the getWD function to see where your R is currently reading from. If that is not where your R script is present, you have to use the setWD, set working directory, and give within quotes wherever your script is present. You can do that, or you can within the source function, you can give it the full path instead of just the name of the script. You can give it the full path of the script. So it's going to be it's going to be C, some depending on whatever your path is. And remember that R is not going to take a um, single forward slash or a single backward slash. It's going to take two backward slashes to consider it as one. Remember last time I told you. So once you are experimenting with these, you will encounter these errors. And if you have any questions or problems regarding that, you have to let me know, because these are some of the basics to run any code. Setting the working directory, sourcing it, just giving the complete path of the scripts while sourcing it. So if you have to practice, and when you practice, you will encounter these errors, and you can fix them based on what I'm saying now. So that's why I'm repeating it over and over, because these are some of the very common mistakes that beginner programmers commit. Okay, so I have run my function, and previously I just showed you about this button over here where you can collapse the function over here and expand it based on how you want to organize your code. And this is only a feature of RStudio. I don't think other environments provide this. So you can collapse and expand based on how big your function is and how many functions you have in a code. So yeah, I have to run this or source it for that particular function to be in my environment. So right now you see that in my functions over here, and if you call it without running it, it's going to error out and print an error message saying that particular function is not present or that function is missing. So the way to call this, you have to use the function name. So once it's in your environment, it's going to show up while you're typing it. And instead of trying to type the whole thing, you can just press enter to use that function. And whatever you give it, now I'm just going to give it one single value, say 100. And default value, I'm going to give it a random value, and I'm going to give it private. So based on that, it ran that function, it passed these values to this function and considered hours as 100, PPH as 55, and client as private. So since I've passed it just one function, just one value instead of a vector of values, this is what I get. You can convert the number of hours to a vector, add more than one value. 100, I have 30, I have 4, and let's see. So I'm adding it 4 values now. I'm making hours as a vector and client also as a vector. I'm going to call it public, private, and abroad. So now I have 2 vectors, and these 2 vectors I'm going to pass it to my function over here instead of one single value. So now it's going to calculate for each value of hours and each value of client. And it gave me results, 4 different results, which means this is calculated for every single value of hour and every single value of client. So since we have 4 in this vector, we have 4 values as the outcome or the result. So similarly, you could change the PPH. The PPH also can be a vector, and you can pass the vector. So it's going to change based on that. So I think now you have seen the utility of this, right? So this function, this functions can be used for data frames. So data frames, you could, in a data frame, if you had hours, and so right now let me just build a data frame. Because these are vectors, I am going to So I'm going to create a data frame right now, which is going to be hours and clients and client. I'm going to assign it to a variable called df. Now df is a data frame, so df can be accessed by, and the columns and values can be accessed by using a dollar sign. So df dollar hours will be the number of hours, and df dollar clients will be client will be that client. So this data frame, this is more of practical use. So your function can be called using the data frame columns. So right now what I'm doing is I'm typing data frame dollar hours and data frame dollar client. So what I'm showing you is a practical use of how you get the data. So whenever you get any external data, you have to either convert it into a data frame or a matrix, depending on what data types you have. If you have strings or and numbers, you convert it into a data frame. If you have just numbers, you can keep it in a matrix. But matrix accessibility won't be this simple as dollar and columns. For remember, matrix accessibility can be used. Matrix can be accessible using the square brackets and then using your hours. So data frame, most of the operations that can run on a matrix can run on a data frame too. That's why it's giving me the data frame hours. But this is more easier, dollar symbol, and because if you have, say, hundreds of columns, all your column names will be listed over here. So it can be data frame. You can directly click on whatever column names you have. So I have a function. I have a question here asking, could you show how we can pass list into this function? So I have not talked about lists until now. So list is also a different type of data structure. It's essentially like an array or a vector. And list can also be passed into a function. So right now, what I have is a type of list. So whatever I have here, as hours and clients, it is a vector, but the similar way you could create a list and also pass it into this function. So you have seen my previous example of the price calculator, right? This one. So essentially what I have here is an hours as a vector and client as a vector. So I'm passing these two vectors into this function. I can change this and also pass a vector into this function, and therefore it's going to create and calculate the values for each of these values within the vector and give a calculation like this. So is that what you asked? I don't know exactly who asked, because so essentially it's going to be similar way. But let me show you a little. Let me jump ahead a little into this section. There are a series of functions that we make. So I have a question asking, do we have to refer to index of list or unlist the list to make vector? So you could do any of these. So right now my function expects a vector, and therefore you'll have basically accessing a list is is using the double square brackets. So if I had a list, so essentially for the other participants, I have not talked about lists yet in my data structures, but lists is um, one of the data types or the data structures that we use within R. So within a list, what you can do is you can have a its structure is as if you have a name, and then you have a name tag, and then you have series of data connected to that name tag. So you can access a list by giving double double square brackets and then giving it the index. So you can pass this into a function. It should still work because a list based on how you stored it, if it's not a matrix, if it's not a list of matrices, if it's just a list of vectors, this should still work within this function should be able to take it. But I think what you're asking is about this. So that we have a series of other functions that work on specific data types. So you could use sapply or lapply to apply one single function to every element in a list or every element in a vector or a data frame. So usually this is an easier way of coding it using lapply, which is list apply, because it based on what it is, based on how many elements you have, it's easier to apply to use this function to use it for a list. So this, I don't have many examples over here. I just have one example, but let us go back and come in a sequence. Let's finish up this example over here. So this price calculator example you have, I just showed you. So this I think you should not have any more problem. So I have another example over here, which you can practice it on your own. Basically, I'm just using another function, which is called seek along client. So it's going to go through every single element in a client. So you could use that. And now we'll go into the apply function of the apply family of functions. So usually using loops or using the for loop or switch or if else is a convenient way to sequence or to iterate through these data structures. But more often than not, you will have to apply like the participant just brought up. I think this is very timely, that more often than not, you will need to apply a certain function to every item in a matrix or a data frame or a list or a vector. So it's easier, and the code also will be cleaner and more efficient if you use one of these family of functions. And this family of functions, there are only a few. There are only three functions in this family, but they are very, very useful. We pretty much use it for more complicated data structures. And you will find a lot of publicly available data sets, and also R ships with a lot of more complicated data sets. The data sets that I shared with you in some of my previous emails are very simplistic way of or representation of data, because those are either data frames or they are matrices. But as and when we get through those sessions, I will share more complicated data sets with you, which if you use the str function, the structure of those, it will display a list of data frames or just a more complicated data structures. And that is where you will have to use these functions. So for now, I just have one simple example. but it will be useful for more complicated data structures, and I will use more such examples in our future sessions. So what is the apply family? The apply family basically takes two arguments. One is the object and the other is a function. So what we are asking, what the arguments really mean is what should I apply a function to, and what function should I apply to this? So we'll get to this in just in the next slide, where it will be clear to you when we go through this example. But let me just briefly go through what these mean. So for just apply function, it can work on three types of data structures. It works on a matrix, it works on an array, and it works on a data frame. So what the functions you can use? The functions that you can use are anything. You can use the inbuilt functions, you can use your custom built functions, and how it runs those functions is you can either run it on every row or column for a matrix. For an array, you can run it on row, column, or any dimension. For a data frame, you can run it on every row or every column, and it gives a series of results based on what your matrix actually contains. So if your matrix contains a vector, it will run that function on that vector and return a vector. And based on whatever the data types these data structures hold, the result is going to be the same. Suppose you don't want this result, maybe you want something else. So there are other two functions that have sapply and lapply. So sapply basically works on vectors, data frames, and lists. It runs these components not as rows or columns, but it runs based on variables, components, or elements. So more examples will make this clear, but for now, just remember that the apply family can take one data structure which has more complicated data structure like a data frame, a matrix, or an array, and run one function on every element of that data structure. So lapply is something that returns a list. Whatever you have, whatever data structure you're running it on, it just returns a list. So let's look at this example, which makes it more clear. What we are doing here is we are counting the number of birds in our backyard over 3 days. So we start with this matrix, then name each columns with the name of the birds. And what we want to find from here is we want to find out the maximum number of each bird in each day. So what we are creating is we are first creating a matrix with these numbers. We want to put them in 3 columns. So make a matrix, use the n column parameter, and specify that you want 3 columns. So the matrix is going to be in counts, and you can rename each of these columns with the name of the bird. So we have 3 names here: sparrow, dove, and crow. So we have this matrix over here. Now we are using this apply function. So you give the apply keyword, then you give it the data structure, which is a matrix over here, counts matrix. And then the second argument that you give it is, if you give it a 1 over here, it's going to run it on each row. If you give it a 2 over here, it's going to run it on each column. So we gave it a 2, so it's going to run on each column, right? And then we should give it which function to run. So if you remember from our very first few sessions, we did use all these inbuilt functions, which is min, max, mean, cumulative sum, sum, average, standard deviation, etc. So this is the inbuilt function max, which is going to pick the maximum value from whatever matrix or whatever vector it takes. So what we are saying in this function, in this one line of code, is we gave it a matrix. We are saying that run on columns whatever function there is, run it on the columns by specifying the number 2. We are saying what function you should run is max function. Run it on each column. So it's going to run this max function on each column of this matrix. So max of the first column, which is the sparrow, which is a sparrow. So the number is 4. That's the max. And dove, the number is 6. Max number is 6. For the crow, its max number is 8. So that's what it's going to return. So you have some other parameters also, like this parameter, which is called na.remove. So it means that if there are any non-available or non-applicable values in a matrix, remove those. Because what happens is some of these functions get confused when there are NA values, especially functions like mean or standard deviation. So when you remove those, using these functions will be easier if you have any statistical functions. So having this parameter is helpful to remove those NA values. Okay. Is everyone able to hear me, or no? Okay. Yes. So there are okay. So there are the other two functions which we have, which is the lapply and sapply, and we will have more examples for it in our next class. These are pretty cool functions, because if you want to run for this one, if you want to run max on every column, you'll have to write three rows, or you have to write a loop, a for loop looping over every column, right? But here you are having just one line of code. This one piece of function applies that function to every column or every row in that matrix or data structure, any data structure that you use over here. So these are pretty useful functions, useful for more complicated data structures, which you will have in future, because most practically used data structures cannot be as simple as a matrix or a data frame. They will be more complicated, and the way you need to organize it just to be able to run your functions on every list or every element in a data frame, or every element in a list will be much easier if you use these apply family of functions. So any questions? We are going to end the session over here. Any questions you have so far? I will send you this slide deck right now, but the videos are taking time, definitely. But I am working on it, and I might have like this and the previous 4 and 5 sessions to you by tomorrow. So if anybody doesn't have questions, we'll meet again on